For 10 years, Air Turquoise have been participating in the creation of the EN norm as part of the WG6 working group. The aim of the EN norm is to bring together the tests to have a unique, objective and repetitive standard that is documented on video. The EN certification comprises of 24 manoeuvres, each of which is categorised into 4 classifications: A, B, C and D. Generally, A is for school wings and D for high-performance competition wings. If a wing does not conform to any of the test standards, it is given an F classification, which means fail. The Air Turquoise test pilots have a strict programme to follow. All tests are carried out at the minimum and maximum weights using a standard harness. Test pilots must repeat each manoeuvre a minimum of 2 times to ensure they obtain the same results in line with the norm. With a 75% collapse, for example, the pilot will repeat the test until they reach the mark on the glider and perform the test perfectly. The results are evaluated by the pilot and the chief test pilot, and if necessary, are confirmed using the video. Air Turquoise work is controlled and certified by ISO. The majority of tests are performed in Villeneuve, Switzerland. The area is very good for testing, as generally there is not much wind, and test pilots have plenty of height above the water to repeat the tests many times.
Alan Soler, I fly for EN certification with the gliders Ream medium at the maximum weight, 105 kilos. The glider 4 risers, dedicated system for big gears. And I'm sitting in an ABS harness, 46 centimeters between carabiners. Okay.
This test is to evaluate the behaviour of a wing during takeoff and to find out if there is any undesirable characteristics. An A classification is given to a glider that climbs progressively and irregularly. C classification is for gliders that have a tendency to overshoot the pilot, and a D classified glider is a wing that has a tendency to hang back. We observe how difficult it is to flare and land the glider, including checking for any undesirable tendencies. If there is no special landing technique required, then the classification will be A. If there is a special technique required, then the classification will be D. The test is to evaluate the speed of the paraglider. We check the hands-up, trim speed of the glider and the minimum speed of the glider. Also, we'll check the maximum top speed of the wing. The pilot verifies the marks defined by the constructor on the brake lines. In 5 seconds, the brakes are symmetrically pulled to check the stall point.
I will make the control movement test. Control movement. Okay, in 5 seconds I will check the mark of the manufacturer. I fix the riser on the left side, and in 5 seconds I go down. Okay. And 2, 3, 4, and 5, and the glider start to lose the flight. No problemo.
Pitch stability exiting accelerated flight. The test is to evaluate the behaviour of a wing once the pilot has released the accelerator. The classification checks the angle of attack and whether the glider collapses or not.
Okay, I pull down full speed, I don't touch anything, I will just fly side of camera, just for to see the behavior of the glider. Okay, I'm still full speed accelerate and I release. Okay, nothing happened, no problem.
The test is to evaluate the behaviour of the glider during accelerated flight when the pilot pulls down 25% of the brake commands. Classification A is for a glider that does not collapse, and if a collapse does occur, then it fails.
Pitch stability operating control during accelerated flight, okay, and now I pull down at 25% of brake range, stop, and the glider is stable, no problem.
Roll stability and damping. The pilot induces maximum roll to the left and to the right, and quantifies whether the wing returns to straight flight without intervention. If the wing returns to straight flight quickly, then it is given an A. In the case of a wing that continues in roll, or the roll is amplified, then the wing is failed.
Okay, the glider is stabilized, fly straight, okay, I go, stop, one time, stop, and I wait until the glider will recover the normal flight. Okay, the oscillation is reducing very fast, absolutely no problem.
The pilot induces two 360 turns with a sync rate of 3 to 5 meters per second and quantifies the ability of the wing to return to normal straight flight without pilot intervention. A is for a wing that exits spontaneously, C is for a wing that continues in the turn, failed is for a wing that accelerates into the turn.
For this flight I will make the gentle spiral now, gentle spiral, okay, on 2 turns, okay, step, and I will check and fly the glider between 3 to 5 meters per second. Okay. Okay. And now up I release slowly. Up. No problemo. The glider recovery very fast. Normal flight.
The objective of this manoeuvre is to quantify the sync rate of a glider after 2 360-degree turns. Up to 14 meters per second, then the glider is an A, and if wing passes 14 meters per second, it is B.
And I go on the right side. Okay, top. I pull down. Okay. One turn. Okay, and I release. And the glider recovery in the normal flight very fast, and I control the dive forward a little bit, and I pass easily 14 meters per second.
The pilot makes a front collapse to the mark on the wing and quantifies the capacity of the wing to return to straight and normal flight. The classification depends on the rocking back and the dive forward of the wing during the manoeuvre. This manoeuvre is performed with and without the accelerator.
Front collapse, okay. I put both air risers without a brake on my hand and stop là. Okay, and it's smooth and a fast reopening. Make the same full speed accelerator. Okay, I'm full speed, I stabilize the glider. The glider is stabilized, okay, and stop là. Okay, no problem, and the glider recovery, the normal flight without a problem.
Exiting deep stall or parachutal stall. The pilot verifies the characteristic of a wing to exit deep stall or parachutal stall and verifies whether there is any undesirable behaviour. The classification depends on the time required and the dive forward on exiting the parachutal stall.
And I pull down the brake and I search the deep stall by the brake. Okay, I pull down. Okay, I continue. The glider begins to lose the pressure, okay, and I release in 2 seconds and stop. Okay, the glider recovery the normal flight without a problem and very fast, okay.
High angle of attack recovery. The aim of this manoeuvre is to quantify the capacity of the wing to return to straight flight after a slow release of a beeline stall. The classification depends on the time required to exit the beeline stall and also the dive forward.
High angle of attack recovery test. Okay, and I pull down slowly, 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 up. Okay, and I really slowly as well, slowly, 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 stop. And the glider recovery. The normal flight without a problem.
The pilot induces a stabilized full stall and assesses the wing's capacity to return to straight and normal flight. The classification depends on the rocking back movement during the entrance of full stall and the dive forward upon exit.
On this axis for full stall, no problem. That's cool. And I pull down, pull down, pull down, pull down. Hop. Super. And now reopening the span, and tap. Okay, no problem.
The pilot induces an asymmetric collapse to the mark placed on the wing by the manufacturer. The pilot assesses the wing's tendency to return to straight and normal flight without any intervention. The classification depends on the pitch angle and rotation of the wing during the manoeuvre. This manoeuvre is performed to 50% and 75% with and without accelerator.
Okay, without accelerator, 50% collapse, the glider is stable, okay, and top. Okay. Okay, 90 degrees, the glider change of axis, no problem. I will make 50% collapse, full speed accelerate. Okay, I pull down accelerator like that. I'm full speed accelerate, okay. The glider is stabilized, and top. Okay, no problem. 75% collapse, normal without accelerator. Okay, I fly front of camera, okay, like that. No problem, and top. Okay. Now we'll pull down accelerator. Okay. Full speed accelerate. Okay. And top. Okay. Full speed accelerate, no problem.
Directional control with a maintained asymmetric collapse. The pilot induces a maintained 50% asymmetric collapse. The aim of this manoeuvre is to see whether the wing will maintain a straight flight and be able to make a 180-degree turn in the opposite direction to the collapse in a period of 10 seconds. The classification depends on the brake range necessary to make such a turn.
Directional control with a maintained asymmetric collapse. Okay. And I pull down 50%. Okay. I keep my axis like that. Okay. And now I will make in 10 seconds 180 degrees. Okay, perfect. That's cool. I'm on the 180 degrees. I release and we can see I have more than 50% brake range. No problem.
Trim speed, spin tendency. The pilot pulls down one brake line to 25% and holds for 20 seconds. Then smoothly and progressively over a period of 2 seconds, he pulls the brake to 75% to see whether the wing stays in positive flight. If the wing enters a 360-degree turn, it is A. If the wing enters a spin, it fails.
Okay, trim speed tendency. 25% brake range. Stop. Like that, okay. I stay like that and I will wait one turn. 20 seconds. Okay, and now in 2 seconds I will pull down at 75%. Okay, 1 and 2. Stop. And the glider doesn't have any spin tendency. That's perfect. I will stabilize the glider. .
low-speed spin tendency. The pilot pulls down to 50% of the brake range, and in a period of 2 seconds pulls one brake to 75% to see whether the wing stays in positive flight. If the wing stays in positive flight, then it is an A, and if it enters a spin, then the classification is D.
Okay, and now I will make the low-speed spin tendency test. That means I will pull down at 50% of brake range. Okay, I'm at 50% of brake range, the glider is stabilized like that, okay, and I put down at 75, stop. And I wait until one turn, I stay stable on my harness, okay, and I check if the wingtip is still strong, if the glider can stay like that, perfect, it turn, I will wait one turn, the glider keep the normal flight, the wingtip is still in flight, okay, no problem, and I release now. That is perfect for this maneuver.
Recovery from a developed spin. The pilot makes a developed spin for at least one turn and observes the behaviour of the wing during the exit. The classification depends on the reaction of the wing once the pilot has released the brake.
Now I will make the developed spin. Developed spin, okay. I pull down at 50% of brake range, 50% of brake range like that, okay, the glider is stabilized and top là. Okay, and I really slowly top. Okay. And the glider is reopening absolutely without a problem. It's a dive forward quite big with collapse, but absolutely no problem with that.
The pilot makes a beeline stall in accordance with the instructions given in the wing's manual. The classification depends on the time taken to exit the beeline stall and also the dive forward.
Beeline stall, okay. Side of camera, I take the B risers, okay, and top. I pull down, okay, and now I release fast and top. Okay, perfect.
This test is to verify the behaviour of a wing during big ears. The pilot looks at the behaviour of the wing during big ears and also the time taken to open completely.
Big ears without accelerator, just by the delicate system, lock. Okay, and I release now, and top. And slowly the wingtips are reopening, no problem.
This test is to see the behaviour of a wing with big ears and accelerator. The pilot tests the behaviour of the wing during maintained big ears and accelerator, and also the time taken to open completely.
And now we're doing the same, but the full speed accelerate. Okay, collapse, okay, and I release everything in same time. Accelerator and big ears. And at this time the glider is reopening by himself without a problem.
Exiting a steep spiral. The aim of this test is to assess the ability of the wing to exit a spiral dive and to check for any spiral neutrality. The classification depends on the time taken to exit the spiral dive and to see whether it is possible to find spiral neutrality.
Behavior exiting of steep spiral. Okay, I take my axis and I go now and stop, and I will check at how many sink rate I will get. Okay, one turn. Okay, the twin release, voila. And the glider recovery straight and fast without any neutrality spiral tendency. That's perfect. That's cool.
This test is to check whether the glider may be steered in case of failure of the primary controls. Generally, the pilot uses the C or D risers and makes a series of 180-degree turns. If the wing remains in positive flight, then it is given an A, and if the wing exits positive flight, it is failed.
I take the D riser, okay, and I turn 180 degrees. But No problem. The glider keeps the flight, and I will control the same at the opposite. Okay. Problem.
If the manufacturer defines a special procedure or other flight configuration, then this will be tested. At the end of each test flight, the pilot fills out a certification report. Once all the tests are completed, the final grade is given to the wing. For full certification, there are, however, additional mechanical tests. This is split into 3 phases. First, there is the shock test. The glider is held up with tension in the lines, and a shock of 1 ton is imparted on the wing, with the car travelling at 75 kilometers per hour. The second test is to evaluate the maximum load. The wing is stressed progressively to 8 times its normal maximum load, as defined by the manufacturer, for a period of at least 3 seconds. The third mechanical test is the line bending test. The lines will undergo a series of 5,000 bending cycles, and afterwards this line will be broken to define the maximum resistance of the glider. The technical file given by the manufacturer will be checked to ensure that it corresponds with the certified glider. The line plan, line lengths and riser dimensions are all recorded to ensure compatibility. The work of the administration is to give the manufacturers all the necessary documents for complete certification. This includes the flight and load test reports, EN certificate and certification stickers. This sticker informs pilots of the EN classification and thus the character of the wing.